Okay, so another slide is there. The significance of this curve, it is given here. Yeah, now a common example, one of these problems is the optimization of heat exchanger network. This is some basic idea. Heating and cooling utilities consumption can be treated as optimization problem. There is nothing but the optimization technique. One of the optimization technique is there. So optimization technique is nothing but the varying the delta T minimum. If you vary the delta T minimum 10 degrees Celsius or 20 degrees Celsius, it may depend. So first thing is that the importance of minimum approach temperature. So what happen in a heat exchanger, the heat transfer area required to transfer a specified heat load is inversely proportional to temperature difference between the streams. As you already know, heat load is inversely proportional to temperature difference between the streams. This means that delta T minimum will determine the size of heat exchangers. Okay, if you reduce the delta T minimum, if you reduce the delta T minimum, reduce in the sense of here we kept as a delta T minimum 10 degrees Celsius. If you reduce it 5 degrees Celsius kind of thing, so what happen? You increase the heat recovery, decrease the utility consumption. So in the value, what do we get? Hot utility is 300, cold utility is 300 kind of thing, and hot utility is suppose 1000 or 100 kilowatt is there. Okay, okay, what happened with that? If you decrease the delta T minimum, if you move the curve, cold stream curve below by keeping delta T minimum is 5 degrees Celsius, what happened? It will also decrease utility. Your utility is also increase. Suppose it will happen 50 kilowatt in Q steam, and what about QCW? It's around 150 or 100 kilowatt kind of thing. But here your expense will be higher cause increase the heat exchanger size, increase the heat exchanger size and capital cost, increase the heat exchanger size and capital cost. So you must keep one thing, reduce delta T minimum will increase the heat recovery, decrease the utility consumption and cost, but at the expense of an increase in the exchanger size and capital cost. Okay, and vice versa. So appropriate value of delta T minimum is determined by economic trade-offs. This value is depends on your economic calculation. You have to calculate capital cost, operating cost and utility cost. Then you will get the optimum value of delta T minimum. Optimum value in the sense of 10 degrees Celsius. Why we take 10 degrees Celsius? Why we take 20 degree? Why not 30 degrees Celsius? Why not 5 degrees Celsius? It depends on capital cost, operating cost and utility cost. Okay, there's a one curve is there, one curve is there, so that you will get it. So delta T minimum is equals to 10 degrees Celsius is the rule of thumb. It can change depending on the fluid service and type of exchanger employed. Graphical approach. We'll start another problem. There are 3 hot stream again and 3 cold stream are there. 3 hot stream, 3 cold stream. The hot stream, there's a procedure is given here. You must read this procedure. Have a look. Delta H versus temperature. we already plot a curve delta t versus delta t. You can also take x and y axis by varying the uh, title section, because here the x axis is delta temperature. Okay, in the previous problem the y axis is nothing but delta t, temperature is there. Okay, so doesn't matter, you can take any scale. X axis you can take temperature, or y axis you can take delta h. The answer must be same, last answer will be same. Okay, so here they plot three curves accordingly. Have a look, the three hot stream curve is there according to enthalpy change. Here delta h value is given, so they plot three curves. Now they their task is to merge these three curves. How they merge will tell you later. Then next curve is cold stream. Next curve is cold stream. Again they plot for the cold stream, three cold stream similarly. Okay, then next the composite curve of the hot and cold stream must be constructed. Now for hot stream they merge three curves like this according to the guidelines. According to the guidelines, I already told you in the previous session, if such kind of section is there, there's a delta h should be 0. Delta h at the T21 T212 is 0, cause it not intersect, here. But what happened here in the H2 and H3, they intersect in the sense there's a common term between them, so they use diagonal rule, or you may plot a problem table method. Okay, so similarly, so this is the hot stream curve, final hot stream curve after use of diagonal rule. Again for similarly for cold stream curve. Okay, have a look at the cold stream curve. These three curves they have merged by use of diagonal rule. So here again it is delta h is equals to 0. Have a look, here delta h is 0. Okay, here. Okay, now this is the actual hot composite curve, and this is the actual cold and hot composite curve. Now merge these two curves in a single graph. Have a look, it look like this, it look like this. So this is not the heat integration, this is without heat integration. You can see this curve. Okay, this is without heat integration. Now what happened, I already told you, you have to move the cold stream curve downward direction by keeping delta T minimum is 10 degree or 20 degrees Celsius. Okay, so here they indicate the values without heat integration, how much QH and how much QC max is there. Okay, so let's see how much energy they can save. Here the one notation is by moving the cold stream curve, partially integrated heat exchange network is graphically represented. Now have a look, they partially move the cold stream curve downward direction, and have a look, there's a middle portion is nothing but integrated heat exchange. Middle portion is indicated as an integrated heat exchange, and how much heat they can integrate or they can save is 15000 kilowatt. Now again my task is not over it, cause delta T minimum I want to keep the delta T minimum is 5 or 10 degrees Celsius. Have a look, here they keep it, around 5 degree or 10 degrees Celsius, and how much heat integration they can save, how much energy they can save is around 56500, and QH, that is hot utility. In the diagram I told you, hot utility at the upward side 8500 kilowatt, and what is the downward side is cold utility, that is the requirement externally, so 10500 kilowatt. Okay, so how much energy they saved? Minimum cooling utility requirement is 10500. Have a look, 10500. And minimum heating utility requirement is 8500 kilowatt. Okay, then total utility is 19000 kilowatt. Total utility requirement is 19000 kilowatt. So no heat is passed through the pinch. Have a look in the previous this section, material balance section. Have a look. Total utility is what? 132,000 kilowatt. Okay, this is for no heat integration. That is without heat integration. The utility requirement is too high. That is 1 lakh kilowatt. And what about this with heat integration? Have a look. Have a look. The utility. So it's around 20,000 kilowatt. So how much energy they saved? How much energy they saved? Just look at the slide number 25 and slide number 28. Okay, did you get this graphical section? How we save the energy by graphical section with integration and without heat integration. There's a comparison between them. Do you have any questions or in graphical section? Do you have any questions? Cause if you see this PPT and try to plot a graph on a graph paper, and then you will get it. Cause in 1 hour this task is too difficult to tell you, cause it requirements is nothing but board or pen putty pencil kind of thing, pen skill, so that easily get it. But the task I just teach you in terms of PPT section, in web session, it's very difficult. But but such kind of understanding is much there. Mm, I already told you in the simple section, simple term. Do you have any questions? Cause I don't think so. Cause next term is nothing but the algebraic method. Next term is nothing but the algebraic method. So algebraic method is too differ than graphical section. Okay. So you must see this PPTs and the previous section problem. Cause graphical section in the 1890 era, they generally use the graphical method, cause they don't know the algebraic method, and the system is not valid at that time. So that's why they use the graphical method. And the graphical method, they got too much errors, so they use the algebraic method, and then they use the software use. So you already plot these curves in hint software. If you have solved the assignment, you I think you have solved one problem on by use of hint software. In that, there's a temperature versus delta H curve is there. There is a one hot stream, one cold stream are there. That is nothing but the graphical as well as algebraic. The combination of the two approach is available in that software. Okay, you must try this in on graph paper.